Hello everyone! Welcome to the first episode of Embedded System. What we'll mainly discuss in this tutorial are all about embedded system, but our main objective really is how we can make this blink. This is a 5mm LED using this. Now what's this? This is a PICk16F877A microcontroller that was designed and developed by Microchip. But before we go further into that, let me just give you first an overview of what embedded systems is all about. So what is an embedded system? An embedded system is a computer system, a combination of computer processor, computer memory, and input-output peripheral devices that has a dedicated function within a larger mechanical or electrical system. It is embedded as part of a complete device, often including electrical or electronic hardware and mechanical parts. Because an embedded system typically controls physical operations of the machine that it is embedded within, it often has real-time computing constraints. Embedded systems control many devices in common use today. 98% of all microprocessors manufactured are used in embedded systems. Okay, so to put embedded systems simply, anything that you program in here, this is our microcontroller, PICk16F877A. It has internal memory that would dedicatedly light up our 7th segment. This is the output device using our input device, which is a push button. That's embedded system for you. So what do you need to do our first activity? Our first activity is lighting up an LED. Of course, first you need to acquire a microcontroller, PICk16F877A. Then of course you need to have an LED. This is a 5mm LED. And then to protect your LED, you need to have a resistor. This is a 220 ohm resistor. And then also you need to have a 222 picofarad capacitor for your external oscillator. And then last but not least, you need a crystal oscillator. This is an external oscillator. Why do we need crystal oscillator? Despite our microcontroller having its own internal oscillator, it's much preferable to have an external oscillator, particularly crystal oscillator, because this is a lot more accurate. So this is just for our clock. What I have here is around 8 MHz. And then of course, aside from having our input and output devices and MCU, you also need to have a PIC programmer. Now what's a PIC programmer? This is just a way for us to communicate our microcontroller to our PC so we can upload a program. We have a lot of PIC programmer available in the market, but I always wanted to use PICkit because it's developed by the same manufacturer of the microcontroller itself. Okay, it's made by Microchip. And then of course, you need to have a digital multimeter just to check the continuity of your connections. And then finally, you need to have a breadboard and a power supply. If you have a digital trainer, that's much better. Okay, so after preparing all of our hardware components, we need to prepare our software as well. Because how can we upload a program to your microcontroller without the software? So what softwares you need? This is one, MikroC compiler, C compiler for PIC. And of course, aside from the compilers, you need a uploader itself, the one that's PICkit2. Of course, this comes in as if you purchase your PICkit2 PIC Programmer as well. How much PICkit2 in the market? Last time I've checked, it's around 2,500. I'm not sure how much it is now. That was like 5-6 years ago. Once you're done installing all of the softwares together, then you can continue with the activity and start connecting all of your components together.
the next thing that you need to do is you need to learn about the pin assignments of your microcontroller. And you find the following information. Just Google datasheet. Datasheet is just a document that would summarize all of the information that you need in a certain product. As for semiconductor, it will present you pin assignments for their microcontroller. Say for example, this one is going to show you an example of a data sheet. Okay, so this is a sample of a data sheet. As you can see, it has all of the following informations that you need in order for you to learn about the 40 plus pin microcontroller. It'll give you the pin assignments. This is what you need. And then also the description that you also need to learn in order for you to program your PIC microcontroller. And then aside from that, you also need to learn about the pin assignment of your PICkit2 or your PIC Programmer as well. And you can also check this via Google as well. You can just type in PICkit2 datasheet. Yes, this is the datasheet for our PIC Programmer. It is here where you can check on the pin assignment of your PICkit2. There. Here. This is the most important information. And then after learning about both of its pin assignments, then you can go and connect the following microcontroller and PIC Programmer together. The 100 nanofarad capacitor here is actually optional.
You have successfully connected your microcontroller to your PIC Programmer and then your PIC Programmer to your PC using the USB port.
Open up your new project. Next, and then find the model or the device name of your PIC, the microcontroller that you're currently using. So since we're using PIC16F877A, that's what I need to select. Otherwise, all of my programs that are not for the following device model will be incorrect. So PIC16F877A, select the following, click on next. Just type in the clock or the crystal oscillator that you have. By default, this is set to 8. And then project file name, let's say for example LED blinking. Then just click on next, 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 finish. And then once you're done, then you can type in your program here. As you can see, just from the first line, you can already tell that this is based on C language. All you need to do is just, I'm not going to explain all of the programs or how this is programmed. My main objective here is to show you that we can actually upload a program in the microcontroller to do a certain function that we need it to do. So we will have a separate tutorial for all of this, for the pin assignments, for the data sheet, for the programming using MikroC. Okay, so once done, you can just click on build program here, build and program. Okay, and then if there are no errors on your program, you'll be able to see the following line here, project linked successfully. So once you have successfully built your program, this will be converted into hex.
Then you should open your Microchip PICkit2 software.
And as you can see, once we have successfully connected our microcontroller, your device model should be displayed if it's correctly connected to your microcontroller. Also, always remember to put this on a 5 volts so you'll be able to successfully upload programs in it. So after this, all you need to do is just go to File, Import Hex, and then just look for the converted hexadecimal program that we just did using our MikroC compiler. and then it should be successfully imported, and then just click on the right button and your program should burn to your microcontroller successfully if you have correctly connected your microcontroller to your PIC programmer. So once done, all you need to do is just follow the schematic diagram. This will let your LED blink at an interval of 1 second. And this is where the crystal oscillator should be connected, pins 13 to 14. And it should have also the 22 picofarad capacitor that I've mentioned a while ago. It's done. You just need to connect that and your LED should start blinking.
Okay, so that's it for our embedded system tutorial for today. For the next session, we'll be discussing more on how to write a program for PIC microcontrollers. So please stay tuned, subscribe to my channel, and bye.